Okay, so we're still on 6.1, and for this, let us take a look at the second objective, in which we will create a sampling distribution from a small population. Now, what is a sampling distribution? A sampling distribution of a statistic is the distribution of values taken by the statistic in all possible samples of the same size from the same population. Okay. So say for example, your population is 10 samples. Okay, so this is your population that consists of 10 samples. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, supposing your sample size is 3, in which case we will select 3 from this population. Okay, samples of size 3. So that's one sample. And say, for example, the statistic that we're interested in is the mean. So we take these 3 samples and calculate the mean. And then we put them back, and then we select another 3 samples. Now, this is, you can do a repetition, right? Because we want to find all possible samples of the same size. Okay, so this time we take 3, 6, and 7, and we get the mean of the 3, 6, and the 3, 6, and 7. Okay, and then we select another, say another sample of size 3, and so on. Okay, so you get the idea, and then we get the mean of this sample. Okay, so that's the sampling distribution in this case of the mean. Let's have an example. Okay, John and Carol have 4 grown sons. Their heights in inches are 71, 75, 72, and 68. Okay, we want to list all 6 simple random samples of size n equals 2. And then we will calculate the mean height for each sample. And then we will look at or display the sampling distribution of the sample mean on a dot plot. Okay. So here are the heights. So we have 6 samples here. Sample 1, 2, 3, 4, 5, 6. Now take note that we are taking 2 at a time. So the first combination taken 2 at a time, we say 71 and 75. And then 71 and 72, and then 71 and 68, and then 75 and 72, 75 and 68, and 72 and 68. So these are the combinations. Now we want to find the mean. How do we find the mean? The mean is we'll have to add the 2 values and then divide by 2. So for the first one, we do 71 plus 75 divided by 2, and that gives us 73. 71 plus 72 divided by 2 is 71.5. 71 plus 68 divided by 2 will give us 69.5. 75 plus 72 divided by 2 will give us 73.5. Then we have 75 plus 68 divided by 2 is 71.5 again. And then 72 plus 68 divided by 2 is equal to 70. So these are the mean. Okay, so let's create a dot plot from the mean. Um, so we can start at 70 and then say 71, 72. Oh, we have a 69.5 here. So we might just as well start with 69. And then your highest is 73.5. So we can end up at 74. So this is the sampling distribution of the mean. Okay, so for the first one, we have 73. and then 71.5, and then 69.5, 73.5, 71.5 again, and then we have 70. Okay. Now, what about if we do the range? Okay, so I'll add in one more column here. And let's get the sampling distribution for the range. How do we find the range? Range is the highest value minus the lowest value. So 75 minus 71, that's equal to 4. 72 minus 71 is 1. 71 minus 68, that's 3. 75 minus 72 is 3. 75 minus 68, that's 7. And 72 minus 68 is equal to 4. Okay, so let me just put in here the standard deviation for the dot plot for the range. Okay, I'll put it on top here. So this one is the sampling distribution of the range. Oopsie. Okay, and we start with the lowest value is 1. So we can start with 1 and all the way up to 7. So 1, 2, 3, 4, 5, 6, 7. Okay. So for the first one, we have 4, and then 1, and then 3, another 3, and then 7, and then another 4. Then you also can get the sampling distribution of the median, sampling distribution of standard deviation. Okay, so whatever statistic you want to use, you can get the sampling distribution for that particular statistic. Now, in the previous example, there are three different types of distribution that we see. Okay, so we can have the distribution of the height in the population, in which case we consider the four heights of the four children. So that's the distribution of the height. Okay, and then um, the second one is the distribution of height in a particular sample. So you take a sample and then you just plot the height. So say we take the two samples, the two sons, two children with height 71 and 75. Okay, and there are four of this that you can, no, six of this that you can draw. Now take note that the first two are distributions. Okay. Now number three is the sampling distribution. So we had the sampling distribution of the mean, okay? And then we had a sampling distribution of the sample range, okay? So I just highlighted the three different types of distribution that we had here. One is you take the whole population, the sample, and the sampling distribution. So the first two distributions deal with the actual height values. Okay, and the third one deals with the difference between the height of your sample. So take note that you always want to use the distribution of and never just use the distribution, because you would want to tell the reader what the distribution, what the dot plot is all about. What does it describe?